So welcome everyone to the March 3rd meeting of the Sewer and Water Commission, Stockbridge Sewer and Water Commission. Pursuant to Mass General Laws, Chapter 30A, subsection 20F, after notifying the chair of the public body, any person may record or transmit this open meeting. This hybrid meeting is being recorded by the town of Stockbridge. The names of members participating remotely will be announced. Any member of the public wishing to speak must first receive permission from the chair. The agenda items listed are those reasonably anticipated by the chair, but not all may be discussed, and other topics not listed may be brought up for discussion by the public body as permitted by law. So, John, would you like to make a motion that we...
Sure. The minutes from our previous meeting are accepted, and I make a motion that we approve them.
Yeah. Carried. First on the agenda is Lake Averick study presentation. So let me introduce myself. I'm Peter Sosha from the Sewer and Water Commission, and to my left is
John Lauridice, also Commission Sewer and Water.
And I believe you know Tony and Mike.
Hi, Brian. I don't think I've met you. Tony Campetti, Sewer Department.
You might be.
Hey. Yeah, Brian. So Brian's
Apologize.
there. There's Brian.
Oh, that's the only one I saw. Everybody's there. Greetings.
Yeah, we're all remote. Yeah.
So Mike, would you like to start us off?
Yeah, so September of 24 to September of 25, we did the 1-year study on the our water supply, Lake Averick, Echo Lake, and we contracted with the gentleman at UMass and ladies at UMass Amherst to do the study. There was a bunch of data collection on our part, their part, together. It was a really, really interesting 1-year study for sure. I learned a lot just by being around these guys and ladies, which was fantastic. So basically what we're trying to do is, one of the main objectives is to find our safe yield for the reservoir. And we pretty much know there's some kind of influence from underground water getting into the reservoir from all these years we've been working with the reservoir. It's always been a really, really great supply. So David, Brian, and Brendan are going to give us the report, I guess, or a synopsis of the report and on their findings. And then I'm sure at some point we'll get a paper copy and be able to, yeah. All right. So
Fantastic.
yeah, so these guys, Brian and David and Brendan and there was Audrey. There was a couple other younger kids. I can't remember all their names. There was some cycling in and out, but they all work for at UMass Amherst, the United States Geological Survey. I think I'm right with that, and they got our information, and I'm anxious to hear the whole the findings, I guess I should say. So, take it away, guys.
Yeah, as Brendan pulls up the slide deck, I'll just say it's been a pleasure working with the town of Stockbridge, and Mike's support and his team there. Really were instrumental in making this happen and the findings. So we're excited to dig into it.
Yeah.
I'll just add that Mike's been such a pleasure to work with. Did a ton of sampling and sort of expanded our capacity by being on site every day. And I'll just add that I'm the state geologist. I work for the State Geological Survey, which is housed at UMass. So not going anywhere and available to be called on for the foreseeable future.
Excellent.
Yeah. It was awesome working with you, Mike. I mean, we had this really cool data set here. It's a really nice little project. I mean, it's just fun to do. Yeah, it was a pleasure. So, um, I think, yeah. So should I just share this? Should I just share my screen? Does that
Yep,
work?
I think so.
Okay.
You guys have a you guys have a monitor there that you guys can see us?
Yeah.
Yes, we have a large screen.
Awesome. Okay.
It
So
says it says sharing's not turned on.
Right.
So might have to.
We're working on that.
Give us a moment.
That's all I can say.
See if Mike's.
Yeah, but I'm a research professor at UMass. I'm in a research team with Dave and a bunch of other people. So that's sort of we had some undergrads working on the project, like Audrey. Audrey was really instrumental. She did a lot of great work. We had a couple others. So we're hydrogeologists, we're researchers, and yeah. So let's see, yeah, it's still getting turned on. Cool.
Yeah, Jennifer just went to grab our town administrator. He's really versed in the control center over there to.
okay. Okay.
Yeah.
Yeah, I mean, one thing just as we're waiting, just to give you a little bit of preview, the watershed that is connected to the lake is very, as you guys know, is very responsive to precipitation. One of the big things that we found is that the amount of water, at least over that study period, that kind of the 14-month study period that we had data from, the inflows to the reservoir, at least from that inlet stream that's the primary feeder into the reservoir, is supplying a lot more water than what the GCA report had concluded based on their statistical analysis using, other gauges in the region. So I think, one of the things that we're going to conclude in this study is that, the safe yield that is currently, calculated by GCA is extremely conservative, and is probably maybe 2 to 4 times that value that they have.
See if you can share your screen now. I think I turned it on.
Yep. Brendan, it looks good. Awesome.
Perfect.
Brendan, are you there?
Yeah, okay. I was on mute. Yeah, that works. So you can see the right screen. It's all good.
Yep.
Presenter
Yes.
to yeah. So I'm gonna do the first little bit, and then I'll hand it off to Dave, and we'll kind of tag team it like that. Yeah. So there's a drone shot that we had of the lake when during the first field work we did. So yeah, myself, Dave, Brian, and Audrey are really the main members here. So yeah, let's see. Is that moving? There we go. There we go. Yeah, so this is a drone shot of the inlet, sort of wetland up there, the
Yep.
inlet stream. Yeah, so really the question we were asking is, what is the source of water to the reservoir, and how does that impact the safe yield? So we really investigated that question here. The approach we took was integrating hydrologic data with isotopic tracers, so hydrogeochemistry, and then sort of integrating that in with our hydrological knowledge. So yeah. This is me and Brian out on the lake sampling the deep part of the lake during the first campaign. That was cool. So some of the main points up front here we'll just go over. Just yeah, the main points. So the groundwater we found that the groundwater input to the lake is probably about 5% of the total lake inputs. So, that's small. It's a small number. I think that there's some uh, there's some caveats in that we're probably double counting some of this. So this is like there's the inputs, the inlet stream, which has a component of groundwater in it, and that's a major component of the inflow. So you know, that 5% numbers probably more like the diffuse groundwater input. Um, all of our observations sort of support our conclusions. So the estimated inflows, the hydrological assessment, the water budget assessment that we did to integrate all of this, and then the hydrogeochemistry support our conclusions. So yeah, like Dave was mentioning, really one of the main findings is that the observations that we've made here suggest that the GZA safe yield estimate is probably quite low. So the safe yield is probably higher than that, which is probably good news, you know. um, yeah, so one key recommendation here too is to just continue monitoring the stream flow of the inlet since it's such an important component of the budget. Yeah. And feel free to ask questions here or interject at any time. Yeah.
I think one of the things that kind of hindered any previous studies was the lack of us having any reservoir level data, which I relayed to you guys all the time. And I started doing that about 3 years ago. So it was there was very limited data on when we had really really dry summers or whatever, or fall. I had no data on what the level of the reservoir was. So that was one of the things. And Dave and we kind of reflected on it when he was here one time, is it couldn't have been more perfect to have that dry late summer, fall that year, summer and fall last year,
Yeah.
to really see how much, we're dragging all the water out of it, but we're still
Yeah.
maintaining very good levels. So anyway,
Yeah, I agree, Mike. And, I mean, I think one of the big, the reservoir and the watershed connected to the reservoir is quite resilient. Yeah. And this was this is about 40 inches, I think, of precipitation over the water year that we studied, which, it's low, but we had a couple periods there where, we had, a 20 or 30-year drought conditions, and, that inlet stream was still, delivering water to the reservoir. And we'll show you in a minute some of the statistics on that. And it's really helpful for essentially updating the data that would go into a revised safe yield estimate.
yeah,
Yeah. I mean, we really covered like two really dry periods and also one really wet period in there.
yeah.
So it was covered the whole gambit, it's good from a study perspective. Um, yeah, so I'll just run through this quick. So this is a map of really all the sites that we utilized here. These purple squares are seeps along the ridge line, base of the ridge line. The green triangle here. I'm gonna do this. Let's see, pointer, laser pointer. Yeah, this green triangle here is the inlet stream where we gauged it. So like right by the dirt road up there.
Yeah.
These lake samples. This is the weir or the outlet. We call this the outlet stream. It's the streams that are down gradient. These red squares are all groundwater samples from private wells that we analyzed. Um, yeah, so we actually ended up doing about 12 different field campaigns, which surprised me how many that came out to be. But yeah, it was quite a few. A bunch of them were groundwater, sampling that we did at the end there. We installed a bunch of sensors. So these are level and temperature and conductivity sensors in the lake and in the inlet and outlet streams. And these are, yeah, really critical data that you'll see some plots later of this, but continuous monitoring data that's really nice. Yeah, 56 total water samples collected and analyzed. Like we were saying, Mike helped out with a lot of additional biweekly samples. And then we utilized the climate data from the DPW station. Yeah, another piece too, we redrew the watershed based on this high res LiDAR data set. So I think it changed the numbers somewhat. I think this boundary up here is a pretty low divide, and so I think it is important. It was important to use this high res data set. These are the numbers that we came out with here. So the lake area, the storage in the lake, and then the catchment area. So this catchment is this black outline. That's the outline. That's the catchment of the lake. Yeah. Yeah.
So
So so quick.
do you guys feel that the state watershed map is a little, it needs adjusting, or? I know Bruce Bach or Bach, I don't remember his last name if I'm, but I mean, this could be, I mean, that report is going to go to the DEP, and I would imagine, I mean, if they did a big study, not a big study, but they readjusted our watershed years ago. But that's just
Yeah.
an interesting point. If you guys feel it's a little larger, or like you said, the catchment area, but that would be something to definitely send this report to Bruce as well. I have his,
Yeah, it changed in its physical layout. I wouldn't say substantially, but it did change. And the area increased by maybe about 5 or 6% of the area based on
okay.
our
Yeah.
assessment.
Yeah. I mean, I'd be really confident with this here. I mean, it's sort of an exact science. I mean, we went in and spent some time drawing this, and like you have to make some decisions. And so, but I think it's the most high quality
Yeah.
watershed area that so
Yeah, I
yeah,
agree.
I would
And I
trust
think
it.
one other thing too that is important is really understanding the main inlet stream and its watershed area is really critical because that there's some portion, Brendan, if you can just kind of point to the areas to the west, like down south of or at
Yeah.
least kind of there are parts of
Yeah.
the watershed where there's some substantial area, but it's not clear if there's a, kind of a direct contribution into the reservoir from that area. But that inlet stream watershed area is really, really critical.
Yeah. This up here.
Yeah, that kind of, yeah.
Yeah. So, yeah, just some quick geology, so this map on the left here is superficial geology, there's superficial materials, and then this is the bedrock. Obviously, the bedrock outcrops, as along the ridgeline there. Abundant thin till is common throughout. There's some thicker till, sort of really down gradient of the lake. I think one important thing is, yeah, there's a lot of bedrock close to the surface or at the surface in the watershed. Um, so I think it implies that there can be a lot higher runoff ratios than maybe you'd expect in a thick till soils dominated sort of watershed. So I think that's an important point here. Yeah, let's see. Yeah, so results. Do you want to take over here, Dave?
Yeah. Can you all hear
Cool.
me all right?
Yeah.
Yes.
Awesome. So, one of the big things that we wanted to do in this project is quantify the water that's coming in and out of the reservoir. So we in hydrology we use a water balance approach. It's like your checkbook. You have ins and outs, and you have storage. In your checkbook, it'd be like your savings account. So we did a very detailed water budget assessment for the dominant inflows and outflows of the reservoir. So the it turns out that the inlet stream. So Brendan, if you can just kind of maybe guess what I'm talking about here. Yeah. So that inlet stream is a really important, the dominant input of water into the reservoir. And because the reservoir is actually a fairly large a percentage of the total watershed area, precipitation, snow and liquid precipitation that falls on the reservoir. It's a really important component. So if you see on this above this diagram, we have kind of the ins and outs. So the ins are the inlet stream flow, direct precipitation. So this is water that's falling directly on the reservoir. And then the outflows are, how much water is going over the weir, over the dam, down kind of into the stream below. How much water is moved to the plant, and then evaporation out of the lake itself. So this is water that's like free surface evaporation that's leaving the lake. And the result of that is essentially water that's either changing in the lake itself, like how much water is being stored in the lake. If it goes down, we're depleting storage, or if it goes up, we're increasing storage. And we've formed this equation to be able to figure out, because as Mike mentioned, we're now measuring the lake levels. So we actually have a measurement of the lake storage. And because we have the GZA study that did the bathymetry of the reservoir, we know the area volume relationship of the reservoir now. So we can actually quantify all of those different pieces, and we end up actually with a residual. And that residual is the imbalance between all of these things. And that residual might be water that's coming into the reservoir from the ground or leaving the reservoir from the ground. So I'm going to walk you through some data that we collected, not going into a ton of detail, but just some of the data that we collected that helps us frame this accounting, this water budget. So next slide, Brendan. So the big piece is the inlet stream flow. So we went out, installed a digital pressure transducer that allows us to calculate the level of the inlet stream. We set that up just above the lake inlet. We did a bunch of manual measurements using essentially a flow meter, which measures the velocity of the stream, and we times that by the area to give us how much water is moving in. So we measured continuously at about like 15-minute intervals how much water is moving into the stream. So next slide, Brendan. So I just want to set up the kind of the climate data across the study period. So we started, as Mike said, in 24. We collected data until about almost the end of November of 25. There's two, Brendan, if you can just animate from here. We had two pretty dry periods. Maybe go back one. There you go. Yeah, we had two kind of dry periods in this record, kind of sandwiched in between a fairly wet period. So we had kind of the drought of 24, and then kind of a drought that we're kind of still experiencing to some extent in 25. But that was then in between, Brendan, if you can go to the next animation, kind of a wet, really wet spring. So we captured kind of a range of conditions of the reservoir, which a lot of times in hydrology, we're kind of handcuffed by the weather and kind of what happens, but we really had a good kind of climate regime to kind of see what was happening in the reservoir. So we had some really dry periods and we had some wet periods. About 40 inches of precip in kind of that annual period from essentially October 1st to September 30th of 25. Okay, next slide. So we don't have a ton of time to go into this, but what you're looking at is a plot over time of the different water budget components. So the blue is the water that's coming in, the orange is the water that's coming out. The kind of the reddish line is kind of the average plant intake. The purple line is essentially water that's leaving through evaporation from from the reservoir. And then the green line is precipitation. So water that's falling, liquid precipitation, sort of liquid equivalent. If it's snow, we have kind of a liquid equivalent amount. So with all of those pieces of information, we can look at both a monthly water budget, like how much water is coming in and out monthly, and then we can look at the annual water budget. And I'll show you what those numbers are now. So one of the big takeaways from this is the lake is fairly balanced in terms of the measured inflows and outflows, which means that the measurements that we took, we fairly we represented those inflows and outflows well. So we actually did a pretty good job of kind of balancing things. What's interesting is the outlet exceeds the inlet, during the wet spring and early summer of 25. You can kind of see that in the data, Brendan, right there. Perfect. And then the opposite occurs, in the fall, and both falls, fall of 24, and fall of 25. So essentially what that means is we're adding more water into the system than is leaving directly through the outlet. And we'll show you what those numbers look like in a little bit more detail. So Brendan, next slide. So these are the same colors, but now this is looking at monthly data as opposed to kind of the 15-minute interval. So one of the things that you can see is the blue numbers are the inflows and the orange numbers are the outflows, and those kind of flip. We have more inflows in the fall. We have kind of less outflows in the fall. We have more outflows in the spring than we do in the inflow. And what's important here are kind of these the red line here, which is the kind of the residual between the inflows and the outflows and the change in storage. And that residual reflects either when that number's positive, what that means is there's water coming into the lake from somewhere else that we didn't measure. And when that number is negative, there's water that's leaving the lake from somewhere we didn't measure. And so that's the groundwater inflows and outflows from the lake. And overall, and I'll show you this in a second, but overall, essentially that number on an annual basis is fairly small. So it seems like in the fall, we're adding groundwater to the reservoir. Exactly, Brendan. And then in the fall of 25, that number is also positive. But in the spring, what happens is the reservoir is high, the water table, it's essentially pushing water probably under the dam, like down below and into, wherever, the watershed ends up. So, Brendan, next piece here. So, the inflows and outflows are the ones that we measured are dominant, and we're importing or exporting water on an annual basis out of the reservoir. This will become apparent and why this matters in a second. So this is now just the annual. This is in millions of gallons of water. So this is annually per year. So on the left side are the inflows, so a positive number. So the inlet stream supports a lot of water into that reservoir. And then second to that is direct precipitation onto the reservoir. It's actually quite a bit because the lake is a fairly small or fairly large area with respect to the reservoir. We lose, Brendan, if we go to the outlet, we lose a lot of water out of the outlet, just overflow and things like that. Some goes to the plant. About an equal amount goes to just evaporation. The storage change, so this is based on the changes in level of the reservoir. So this is from the volume of the height change in the reservoir is fairly small. And then that last term there, that is the water that's imported into the reservoir, probably from either groundwater or surface inflows into the reservoir that we didn't measure. Small seeps. There's a lot of seeps on the west side of of the reservoir or lake that bring water in. So Brendan, if you can go. So again, the inflows and outflows, they dominate that. But one of the really important things, and I'm going to come back to this in a minute after Brendan talks a little bit about the isotopes and the geochemistry, is that we've quantified the inflow volumes and how they change throughout the year. And one of the things that we found is that that inflow stream provides a lot more water into the reservoir than estimated from the statistical analysis that GZA did. And so I'll show you some of the details in a minute, but essentially what that means is that the drought basin yield of the reservoir is gonna increase. So from this information, because now we know how much water is coming in and we know the volume of the water from the GZA report, it gives us a sense for how long a water molecule would spend in the reservoir. So that's what we call residence time. So like how long would the average water molecule spend in the reservoir? And it's very fast, 3 months. It's very, this reservoir turns over fairly quickly, at least kind of in that, kind of surface active layer. So it's this is consistent. You'll see in a second, this is consistent with the geochemical data that this is a very responsive system. And that has implications for, how you all should probably, you're doing a good job protecting and managing that system, but just, it's very fast. Things happen quickly. So Brendan, I think this is where you transition into.
Yeah, I think so. Cool. Cool. Yeah. So thanks, Dave. Yeah, I'm just gonna walk through. We used essentially four different hydrogeochemical tracers, you could think of them as, to really look at the sort of this hydrological water budget with a different data set to sort of confirm or adjust our findings. So one of them is the elemental hydrogeochemistry. So this is like the ion. This is the dissolved elemental ions in the water. Um, this yeah. So obviously, like, beyond water quality considerations, this is a really useful tool to trace different water types and really similarities or dissimilarities between them. This plot over here, we call it a Piper plot. We took all of the water sample data and we plotted in this Piper space, which essentially normalizes it so we can look at them together. And yeah, so we found that there is, wait, let me just go to this. There's like they're really clustered together. You know, the the green triangles here are the inlet, and the outlet are sort of clustered all here along with the lake. The groundwater are these red squares. The groundwater sort of evolves, the way we call this evolving, when it's sort of moving off in this direction. And so there's a group of groundwaters um, that look similar to the seeps that we have on the western slope of the watershed there. Um, these sites here are really to the west and the south of the lake watershed. Um, and I think it just indicates that the lake and the inlet water and the lake aren't really dominated by these groundwaters. Like these are very different, very evolved, we call them, groundwaters that have this signature way off here, whereas the inlet and the outlet and the lake really cluster down here. I think that's the main takeaway. Like, if we had a groundwater dominated system, like if this was like deep groundwater or stored groundwater that was really feeding a large portion of the water in the lake, we would see the surface waters falling off in this direction. So that's sort of the main takeaway there. Yeah, I think it supports our findings of a small groundwater contribution to the surface water. Yeah. So the stable water isotopes, these are a really key one that we had Mike collecting too. We have a lot of data here. This is really, really great data set. Um, they're really conservative tracers, these. So this is like the water molecule itself. These are the isotopes in the water molecule. So they're really conservative. They're really reliable. We get a source signature essentially from when the water it is recharged into the ground essentially or into a stream. We can trace that, so we can really fingerprint the waters. These plus signs here are the precipitation data that we collected. The inlet stream are the green here. The groundwaters from that survey we took, the seeps, and then the lake waters are these blue circles over here. As you can see, the groundwater sort of cluster together with the seeps, which is good. You know, we expected that. The seeps are related to the groundwater. They're sourced from, at least a portion of them are sourced from sort of this groundwater here, this like deeper groundwater, you could think of it as. The inlet stream varies quite a bit seasonally. So this is another indication that there's a lot of recent precipitation that's moving through the watershed essentially. So this is like cold season, this is winter, fall, early spring water that tends to fall down here. This clustering up here is the warmer season, so like the summer, like from thunderstorms, and they cluster up here, and then the lake waters actually interestingly have this. There's two trends to them. So these are without getting into too much of the weeds here, there's an evaporative trend that happens with isotopes where when you evaporate water, they fractionate and they move off in this direction. This is a classic signal of sort of lake or surface water. We have really two trends here. And what we found is that this grouping down here is 2025, and this grouping up here is 2024. So it seems that perhaps it was because the the winter before 2024 was quite warm and not very snowy, and the next winter was actually quite snowy. And so I think it shifted. So those 2 years really have different fingerprints of the source of water. It's not it's not super important in terms of like the safe yield of the lake, but it just sort of tells us how things are functioning, that they're really responsive to changes in seasonality. Different years have different input signatures. But yeah, again, I think the key takeaway, as we've been saying here, is that the inlet stream and the lake respond strongly and quickly to changes in the input source, so they change seasonally quite rapidly. And yeah, and then yeah, I think that's there's clearly some connection to the groundwater. I think the fact that we have these data clustering here, that if you follow this trend, this is what we generally see when we want to think about connections of sources. This trend is pretty closely aligned. So the fingerprint of these waters is not that dissimilar from the fingerprint of the lake water and the inlet water. So I think, there is a groundwater connection. I think my thinking is that some of this is actually just groundwater feeding the inlet stream, so feeding the wetland sort of base flow in that area that's getting through. And so we're capturing it as the inlet, but it has a portion of groundwater in it. I think that's what that would say there. Yeah, quickly. So these are the isotopes by season. So this is the warm season on the left here. This is the cold season. Obviously, we have less in the cold season just from the fact that we sampled the groundwaters in the summer here. But I think, and again, you can see that so this sample here is deep in the lake. Um, and this is the seep here. They don't, these 2 points specifically don't vary as much as say as these as the inlet and then the sample at the surface of the lake. They vary quite a bit more. So I think this again shows that there's a there's a rapid connection to the precipitation. I think it's less rapid in the seeps and in the deeper part of the lake. Um, yeah,
We noticed that when we had rainfall, when we were low and the reservoir
yeah,
responded very, very quickly to rain, to 2 or 3 inches of rain. It would come,
yeah,
it would come up really quick.
yeah. I mean, that makes sense. We see it's some of the some really high runoff ratios we're getting, which I think we'll talk about it a bit later. But yeah, it seems like the lake itself captures a bunch of water, and then also the inlet seems to be capturing and transmitting water quickly. So yeah. Yeah, so is an interesting plot. This is just the stable water isotopes over time. So the green here is the inlet stream, the blue circles again at the lake surface, the surface water, like the surface lake sample. And you can see here the winter precip in the inlet stream, this signature, uh, it declines pretty quickly. Once we hit sort of the cold season here, you can see sort of this like inflection point here where you start to get mixed rain, snow, and then some snow, and it really changes the isotopic signature here. Quickly, I think is the point. I think also some there's some lag, so the inlet stream responds more quickly to the precipitation events than does the lake, just probably from a storage perspective. There's more water to move and mix, but you can see that it does respond, within a couple of months to sort of changes in this season. And then again in the summer, it's sort of the same thing. It responds pretty quickly once we get, bigger rain events. And yeah, and so these couple points here are sort of large events that we pick out. Um, and yeah, I think
What,
you can see, yeah, go ahead.
what's the,
Yeah.
what's the bottom green and is that rainfall? Or what is the graph on the
Yeah,
bottom?
sorry. Yeah, so I took the plot that we had shown earlier with the temperature and the precip,
Okay,
and
yeah.
just sort of here so we can see, the climate.
Yeah, the
Because
comparative.
yeah, these isotopes are a direct reflection of the climate, and so we're looking at how they're responding. Um, yeah, so like, this sort of winter rain, snow period, you can see reflected in here. And then I think, it's somewhat, the summer precipitation is somewhat different, obviously. There's, thunderstorms and they hit certain areas and they don't. So, but I think you can see that the general response in the lake and in the inlet pretty quickly to a change in the climate. One thing you can see with these large events, you can see that it seems like the lake and the inlet do respond differently to these events, which is probably to be expected. I mean, I think this one, like this sort of spring one, was a pretty big event, and they sort of responded in kind at the same time. But I think this summer event, the lake seems to have jumped up really quickly to the rain event, whereas the inlet stream didn't really respond, which, like you were saying, I think is like the thunderstorm was localized maybe, and it wasn't up in the watershed, or there's a lot of things that could explain that, but they have some different response. But again, yeah, just to summarize, I think that the most important point is that this data shows, like our residence time data, that there's a slight lag, but they respond. The lake water especially responds within 2 to 3 months of a change in the climate, which is reflected in the isotopes. Yeah. Um, yeah, and so also just quickly, we actually did an isotope-based mixing model, which is essentially a water budget using the isotopes to sort of check our physical water budget, and it really was consistent with our water budget. So I think that's a really important thing. It's a completely independent assessment that just uses the isotope data. Um, and so, yeah, I think that really supports that our water budget assessment here was, accurate. Um, yeah, the tritium data here, we took so there's a radiogenic isotope in the water molecule itself, also called tritium, that really gives us it gives us an estimate of age of the water. And yeah, and the data that we got is pretty consistent. It's not very variable, so there's not a ton. I'd say there's not a ton to gather from this, except that um, so 75% about of so yeah, this percentage here is a relative number based on the precipitation signal. We can basically get about what amount of that sample. So these samples we have here was really recent precipitation water or was sourced from a groundwater source. The groundwater source is depleted in tritium, and so you can sort of differentiate these two. And you can see that they're pretty similar. There's not a ton of differences. I think it just basically shows that there is a groundwater component um, that is important. You know, especially if you look at the inlet here, like 25% of that water is water that has very little tritium in it, and so it's been in the ground for a while, and I think this sort of 75% is a pretty decent estimate of that. So like, the inlet stream is getting a sizable amount of groundwater that's sort of base flow that's supporting it. This is not diffuse groundwater, like that sort of residual number we're talking about. This is like the inlet stream water is composed of a portion of groundwater. So I think this supports the idea that there's a stability in the system, that even when you have a drought, the inlet stream keeps running, or at least that watershed keeps delivering water from groundwater. Yeah. Yeah, and then lastly, we used radon. So radon exists in natural waters. We can measure that, and it's the source of that radon is uh, from the ground. So water that's been interacting with the atmosphere has very little radon in it, whereas water that's been in the ground without interacting with the atmosphere has a substantial amount. I think you can see that the outlet stream and the lake surface and also the seep up here have very little radon, so they've been sort of interacting with the atmosphere. The the deeper lake sample has a substantial amount. I wouldn't say this is very, I mean, it's red here and but it's not like these are groundwaters that are in the hundreds. It has some though. I think so. There is some groundwater getting into the system to have this in the deep lake. I think the inlet stream also, the fact that it's a surface stream and it has some radon in it, means that it is getting some groundwater contribution. So yeah. Let's see. I think yeah, Dave, do you want to take it over from here?
Yeah. So,
Okay.
thanks, Brendan, for going through all that data. I think as we said from the beginning, the data sets, the physical water budget, physical hydrologic data sets, and the geochemical data sets kind of are painting a similar picture. So one of the things that's important to remember, the safe yield for the established safe yield for the lake or reservoir at the moment really is driven by two things. What the drought basin yield is, which means how much water is coming into the reservoir during dry periods, and then two, how much reservoir storage is depleted during those periods. So the thing that we studied the thing that we studied was like how much water is coming into the basin. So GZA estimated about 32 million gallons of water per year come into the basin during drought conditions. And that assumes that the whole watershed contributes to that stream flow. And then they use that number to estimate essentially a 1 year drought condition to arrive at a safe yield of about 28 million gallons per year. We estimate that the essentially drought basin yield based on the inflows and based on our assessment is probably closer to about 80 million gallons per year, at least based on what we measured during the water year 24-25, which had some pretty significant periods of dry conditions. So our assessment is that, what's been put out there from the good work that was done by GCA is a very conservative number for safe yield. So let me show you this plot, and then we'll get into kind of what this means and kind of the implications for you all. So this plot that I'm showing here is what's called a flow duration curve. Essentially, what this means is that if you go to 50% on the succeedance probability, 50% of the time, let's say, in the inflow stream, based on the data that we collected, you would have close to about 500,000 gallons per day of water coming in. If you move to the right, that curve slopes down as like about 90% of the time we have, based on our data, about 220,000 gallons per day from the inlet stream coming into the reservoir. GCA estimated, based on the statistical analysis and the products that the state uses, that number to be about 88 or 89 gallons or 88,000 gallons per day. So that number 220 versus 88, that's a pretty big difference. And this is based on real data that was collected at this site. So what that means is that that drought basin yield, the amount of water that's coming in during dry periods from the inlet stream, is quite high. And I think with perhaps some additional years of collecting data, and the data that we have to date, could be a basis for increasing the safe yield. And so one of the really important things that we found is the inlet watershed is very efficient at moving water. About almost 52% of all the water that falls during a year onto that area makes it into the reservoir. That's a large number compared to other watersheds regionally, and I think it's probably one of the reasons why the reservoir is as really resilient as it is. And I think it has to do with the topography, it has to do with the geology. Yeah.
That's good news.
Questions from the commissioners?
No, we thought that all along about the watershed, that we always had an excellent watershed, and that's one of the reasons why the lake is so, we have such a great reservoir, and the recovery time is one of the reasons because of watershed. And you're also talking about more of the bedrock too, that adds to this.
Yes. Yeah, that runoff ratio. So the runoff ratio is defined as essentially how much water is coming into that stream versus like how much is coming out of the stream versus how much has been put in. And 50, 50-ish%, which is the number that we have, is very, it's a high number. So it essentially reflects a very responsive system, one that's very well connected. One of the other, if Brendan, if you can go to the next slide, I think I have a summary. So yeah, so just go back one, just to that green text. Sorry. So this Q90 statistic is really the basis for the safe field determination. And if you work through the math, that GCA did or a similar, consultant would do, you're looking at least probably doubling, the safe field for the reservoir based on the data that we collected during this year.
Wow.
So, Brendan, if you can go to the kind of the next slide. So, I'll just I don't want to spend too much time on this because I'd like to have some discussion. These are all things that we talked about. Reservoir is a large portion of the watershed. The reservoir residence time is fast. Inlet stream is important. The amount of groundwater coming directly into the watershed or into the lake seems to be small. The safe field is probably larger than what's estimated by maybe a factor of 2, maybe higher. If you can go to the next slide. So the implications of this, I think the approach that GZA used is appropriate. I think it's going to be improved by actual data collected. The reservoir stages that Mike was talking about, the inlet stream measurements that were taken, and the system responds very quickly. And I think you guys are doing a really great job of protecting that watershed. That's part of the inlet stream, and that should be, obviously a focus of kind of continued effort. And then the last slide, Brendan. So I think what's one of the things that we're recommending is as much as possible to continue to monitor the inlet stream flows, collecting data that allows you to relate the stage or the level of the inlet stream to how much water's moving through. I think one of the still outstanding questions we have is, like over what area is the inlet stream draining to the reservoir? I think if we doubled the area, it would kind of make hydrological sense in terms of like if the whole watershed was kind of, if the ridge line that's to the west of the reservoir was contributing water to the inlet stream. I think there's a lot of argument for why that could be the case because of the bedrock, the shallow bedrock there. And then if you wanted to kind of continue to do some of the other sampling of the isotope data that was collected, that was helpful. I think that's something that could be done, very, very cheaply and economically. So anyway, I think the conclusions here are that one, that inlet stream is very efficient moving water, and two, the safe field of the reservoir based on the data that was collected, could be increased if that was something that was, in the interest of you all. So.
What about the monitoring wells, shallow monitoring wells, Dave?
Yeah.
What would that consist of?
So, I mean, initially, I think that could be these could be hand-driven, slotted PVC pipe into the wetland area. Maybe just up gradient of where we measure the inlet conditions to measure kind of water levels in that wetland complex.
Yeah.
A more kind of advanced campaign might be to have some wells that are dedicated, that are designed to be open to the bedrock aquifer, so we could measure kind of levels and hydrologic conditions throughout throughout the year. So I think there could be kind of two phases of that. There could be something that's, pretty economical in terms of things that could just be done with, like a drive point that could be driven and look at kind of shallow conditions, but also something that could be maybe a little bit deeper into the bedrock. And again, I think the idea with collecting that data would be to try to understand the aquifer or potential aquifer that feeds that inlet watershed area.
Gotcha. So like the salt slug tracers and all that, and we can talk about, I mean, obviously, if we're going to do any isotope testing or sampling, you guys could still be involved with that on a quarterly basis, or how?
Yeah, I mean, those analyses are not. I mean, the biggest effort is your time usually, in that, having the samples and getting the samples to us. And I think it's worth at least continuing that, for another year.
Okay.
One thing, Audrey, who she's in Australia right now, so time is not good for her, but she's going to work up some of this data for a senior thesis for her project. So, there's going to be a pretty significant in-kind contribution to kind of looking into some of these additional questions based on the data that we have.
Yeah. One thing, when we had our first meeting years ago on Zoom, and I think that was like the second or the third slide showed the geological bedrock formations, and I always thought it was very interesting that there was kind of a seam of bedrock right through the middle of the lake, and I don't know if Brendan could zip back to that towards the front of and I don't know if it can get zoomed out or anything, or it's kind of has to stay that. But there was a picture of two geological.
Yeah.
And that seam that runs through the middle of the lake.
Yeah.
Yep.
Yeah, it was I think it was, oh yeah, there it is. Yeah. I'm looking at the bowl. Yeah.
Yeah.
Yeah, there's a contact between two units that sort of sits underneath the lake. Yeah. So
That's interesting.
the inlet stream kind of follows it too, I think
I think that's why the topography is the way it is. And the way that these geologic maps, because we don't have full exposure.
Sure.
There's some uncertainty in like kind of where that contact is.
Sure.
But I think it's important to understand that, this is an area where, these rocks are heavily fractured. There's some shallow dissolution features that could be playing a role. And I think it's one of the reasons why this inlet stream is so responsive. I mean, 50% of a runoff ratio is normally, at least in my experience in these systems, you might expect maybe 35% of precipitation to kind of end up in the stream. And this system is quite responsive. And I think is the reason why, as I mentioned earlier, the reservoir behaves the way it is.
Yeah. Interesting.
One of the things I find really interesting is how clever the old timers were, because now we have real results that geologists kind of did.
Yeah.
And these guys kind of seeked it out
Yeah.
in the field years ago and
1880s.
knew where to site this thing.
Yeah.
And then one of the things that's always amazed me about Echo Lake or at Lake Averick is that, I've been around it almost 30 years, but it's been around a long time before that as a reservoir, is we don't need to control the level. It controls itself
Yeah.
kind of through the flow in and out. And thankfully we don't have to,
Yeah.
build a dam there and
Self-sustaining.
yeah, it's a self-sustained.
Yeah. Yeah. No, I've worked on projects, all over Massachusetts and the world. And, the more you talk to people that, have lived and experienced these things, that information is, just as valuable as like the analysis that we collect. So,
It's just so interesting to see the backup, to see it really provided. And then,
Yeah.
Yeah, yeah.
to me anyway.
Well, we will certainly talk and maybe plan on things in the future. I don't know where we all ended up at as far as, the finances go. I don't think we're hardly, I don't know if we put much of a dent in what we allocated, but unless you got a big invoice that's coming soon, but unless Mike's been signing those too, I really don't know, but that's all.
I would imagine that, I don't know, Brendan is the most expensive person on our project, so I'm not billing anything to you guys, but
You put a lot of effort in. Audrey used a lot of time to,
I mean, Audrey did the majority of this work, and she should be commended for that. But
Oh, yeah.
but Mike, I think, in terms of like next steps, obviously kind of the finalized report with the methods and everything in it that support what we showed you today. And then really thinking about, like I did some back of the envelope kind of calculations of just based on kind of what GZA did in terms of the safe yield. Because what you do is you take how much you guys are authorized to use out of the reservoir, how much comes in during drought conditions, and then how much the reservoir might be depleted because of that balance, right? And then that number then is the basis for your safe yield. And that if you use those inflows that we calculated, that number is large. It's larger than what you have, and whether or not, that's, something that you want to pursue. And I think collecting some more data over a couple of years, actually having some good inflow data in that inlet stream will help you, justify that number even more.
Okay, great. We'll certainly talk after, in the near future and figure stuff out.
Will we be getting a report on this?
Yeah, we'll be getting copies of this, obviously, right?
Yes. Yeah.
Good.
we're gonna write this up in a report. Yeah.
Excellent.
Yeah, I mean, I think, like I said earlier, the work that was done by GZA, the bathymetry study, the volume area relationship for the reservoir, that initial stuff really set you up well to really collect some additional data that then gives you some insight into what's happening, or into the reservoir.
Yeah, cool.
Awesome. That was a really fun project to work on, so I appreciate your support.
Yeah, well, we appreciate it all, that's for sure. We've been trying to pin down this number for a long time.
Yeah.
And, we use, as you guys have seen all the data that I send you for monthly flows withdrawn from the lake, and we're usually right around 52 to 60 million gallons a year. And I think you guys came up with 88 million gallons a year. So
you're barely tapping into the potential.
Yeah.
But that's good.
That's great news.
Yeah.
Really is.
Yeah. And especially, I studied drought around New England, that 24 drought, and then what we had kind of maybe into kind of mid to late summer, those are some pretty big events. Those are 20-year events, and that reservoir held steady. I mean, it dropped obviously below the flashboards, but it's pretty resilient.
Yeah, it is. And I was texting you the levels after how much we were using, and you were like, "Wow, that lake is pretty resilient to." Yeah.
Yeah.
Excellent. That's great.
Okay. Thank you.
Yeah, thanks.
So we'll be in touch, Dave and Brian, and we'll talk about future stuff and what we need to purchase and what we can do, and yeah, we'll go from there, and we'll be you guys can send the reports or out digitally, and if you want to do paper too or whatever, or however you want to do it, that'd be great.
Sounds great. It's on Brendan's to-do list. So
Excellent.
To do. Always a good.
Sounds good.
All right.
Thank you.
Thank you. Thank you very much.
Guys. Appreciate it.
Thank you.
Have a good day. Have a good night.
You as well.
That was great.
That was great.
Yeah.
Just exactly what we wanted.
Very informative.
Yeah, that's nice to know that we always thought, and that was the one thing, like I said it to them earlier, you just, yeah, you can have a good drought, but if you don't know the level of the lake, all that data is almost worthless without having what's left in the lake.
Really how important that feeder stream.
Yeah, I was quite shocked at that.
Me too. I didn't realize that.
More groundwater.
Well, I think what they alluded to is that I think a lot of the groundwater feeds that
Stream.
wetland area.
Yes.
Yeah. See, that's the issue I had with the Sisto issue. The property up there that's feeding into the stream and whatever. And
It's interesting too that the water, I mean, that LiDAR is so exact. It's pretty amazing stuff. So it'll be interesting too. We can send that report to Bruce Bach, who's in the Boston office of DEP, and he's watershed. And I've talked to him about this study that we're doing, and he said he would be very interested. And he said, you have the cream of the crop doing your survey.
it certainly was in depth.
Yeah. Yeah.
Well, they were all doctors.
Yeah.
I mean, it's not like a first year student.
The
Yeah.
state watershed map would get redrawn.
It might be the boundary, because these guys, when they redid it for us back in 2007 or something, they just use mapping. They kind of look at topography and be like, okay, we want to see everything that's kind of going to the lake.
Draw a line.
And these guys, they walked a lot of it and said, this is going to the lake. They were looking at, the little gullies and draws that are in the mountain on the backside towards the lake.
There's a lot of them.
There's a lot of them.
Yeah.
So, yeah, very, that's great. It's great news. That's what we were all hoping for.
And the other thing is if, you needed to use more water or sell more water to somebody,
Yeah.
Yeah. Yeah. We have the capacity.
Yep.
if there's expansion in town.
Yeah. And then that's one of the things the state always wants to see. I mean, we're permitted to take an average of 190,000 gallons a day out of the lake. Our average is usually 160. And I'm working on the annual statistical report. Christine put a bunch of information for me together. That number is always interesting to see as well. How much we take out, how much we, are unaccounted for water, all that stuff. But yeah, that's, and then I talked to the watershed. She actually called me, Allison Taylor. I talked to her last week or the week before, and she's anxiously awaiting this report too. She's like, I can't wait to see the numbers, so.
Yeah, we're really, really.
Yeah, DEP will be very happy to see this. They're anxiously anticipating this report as well. So,
Yeah.
and they applauded us for moving forward on paying to have it done, rather, because a lot of the bigger places, like a lot of the big reservoirs, they do it. The USGS does it for free. they just go and do it. And we allocated $50,000 for this project. I've signed one bill for like $2,200. So I don't know where we lie with all that, if they're,
Maybe there have been
Again,
others,
she's
but
doing her thesis on this, so
yeah.
that's good. There's a lot of gratis coming in.
Yeah. And Audrey she was out here all the time. They just all super nice kids and it was, we all enjoyed each other's company and doing the work together. So I learned a ton from all of them. It was good.
Good.
Yeah, very good.
Yeah, good.
What else do we have?
So, did you accept the minutes?
yep, we started, we
Okay.
approved the minutes.
Yeah, I'm sorry,
This was
I was
fine.
coming back from Albany in a blizzard. Trucks off the road, cars off the road. Anyway,
So we're up to this. Red line day.
okay. Have we heard?
No word.
Okay.
So just to kind of give you guys a little revisit the synopsis, because a lot of the discussion was done through like our DPW meetings and stuff with Mike Canales. Basically, we sent in a letter, and I want to say it was a date in June 24 that we gave them to come up with a plan. That's all they had to do, come up with a plan
Well, that's what they said they were going to do.
on what to mitigate.
Yeah.
And they did come up with an engineer's estimate of what the runoff was in a 1-inch rainstorm. And it was around 100,000 gallons.
Okay.
In a sustained 1-inch prolonged. So anyway, their plan was when they tore down their elevator building, which is that big brick building behind the museum,
Right, that was to come down.
somewhere in that area, there was going to be a leach pit or some kind of drainage, groundwater drainage built into the system.
Right, I remember that.
And, I get it, they probably have constricting budgets and everybody, but I guess we need to reach back out to them and just see where we are with that.
Progress.
Yeah.
Yep.
Kind of knock on the door again or beat the drum. And
So how should we do? Should we send a letter? to
I was
them?
going to ask Mike, we have a meeting next Wednesday.
Okay,
And then, maybe we can just give you guys an email about what his thoughts on how to proceed.
yeah.
Keep you in the loop, and if you guys make
Yeah.
suggestions, we can kind of do that.
It seems like
Kind of get a
if
little chain going.
we, send a letter out to them and actually request a response.
Yeah.
Get back to us. Yeah,
So that's where we're at.
okay, good.
And how many dig safes have we seen for that building to come down?
Did it come down finally? I haven't been back there.
No, I don't think it's still up, I'm pretty sure, but we get.
It's still up, isn't it?
I don't know.
Is. And we've seen dig safe after dig safe after dig safe to knock the old boiler building down or whatever. And
They're
still there.
Tore the fire escape off the end of the building.
they tore the south porch out.
So that's,
Whatever that.
That building's a work in progress.
Yeah.
There's no end to
It's
that.
old and-
You peel that onion back, there's
can you
no,
imagine the yearly maintenance of that bad boy,
there's no stopping.
standing up that old house of mine.
It's a long way around that building.
Yeah,
So that's what we'll do. I'll
Okay.
write it down for
that sounds
our
good.
Wednesday meeting and
Do we want to begin discussing rate increases?
Well, I was going to suggest tabling this until Mike Canales can be here because he left for the day.
Okay, because
yeah, he's got it all.
Rosie left a message in your office, I think. And I said, call Mike, and she got Mike anyway. Did she tell Mike?
Mike came in here and said he was heading home because of the roads.
Yeah.
And we will just, he said what he'll do is if you guys want to have another meeting next week, just on the rates, or we can wait, but, because it's not going to be till July.
He didn't tell you I was going to be late?
Yes, he.
Oh, yeah. Yeah, he did. Yeah.
Yeah, we knew.
Yep.
Yeah, I don't think we should dig into that.
No.
What now? No, let's do it with Mike.
Yeah.
Let's do it with Mike. Because I have thoughts about what I propose on this race, but let's wait till
Yeah, he's got a
get everyone
whole,
together.
what I can do too is, and I don't know if he sent you guys the spreadsheets, but we can, when we talk to Mike Wednesday, is it next week? Yeah.
Next one.
Or I can ask him tomorrow. I can just send those to you, or he can send them to you so you can look at them. And you can change the percentages, and it changes the,
He's got ideas.
he's got all kinds of stuff.
Mike, when you're talking to them, let's see if we can, get an idea, a tentative meeting.
Yeah.
If we want to do this like next week or so with Mike Canales,
Sure.
Yeah,
see what's available.
Yep.
I have no problems with that.
Yeah.
Next week.
Yeah.
Sure. You're going to still be here?
Yep.
Okay,
I'm leaving Saturday, next Saturday.
okay.
Yeah, we should do it before Tony's. So
No, we're
Tony-
gonna do it, we're doing it before
Yeah.
Tony leaves, yeah, yeah. So next week sometime would be good.
Yep.
Okay, great. Okay, Tony and Mike, any concerns?
Not really concerns. I'll just give you guys a couple things I just keep you guys up to date on. So when we started the budget process, the sewer department had a surplus, and we're going to use some of the money for one article reading, Lake Drive in Averitt Road Engineering. You guys voted on that last time. That's going to be on the town warrant.
Good.
And then there's going to be another article with the rest of the money that's going to read sewer department maintenance and repairs.
Perfect.
So as Mike and I have learned since we've started an enterprise fund, we can't have a sewer surplus just gaining momentum. We have to use between 85 to 100% of our budget every year.
Then we will use it.
Yeah. So, and Mike likes to see us around 90. So, so it has to go to something. We can't just bankroll it. Just so you guys know, just remember. Because
Well, we
we kind
have
of,
some projects that we could,
no, I know. And we have things that are going wrong. So, and I'll lead into that. So last week we were having a problem over at the Glendale pump station with some control issues in the cabinet. And they got to the bottom of it pretty quick. And I'm usually paying for the day and travel anyway. So we switched gears and went over to Goodrich, which has had a seal light fail on for about a week. It won't reset. Pump running, but there's no way to tell what's wrong. They're in a submerged pit in a wet well. So they pulled it, and it was determined that the mechanical seal had failed. So that they were wondering what I wanted to do. I said, well, there's no reason coming back and paying you to come back to pull it. I mean, we know we have to pull it. So they pulled it, and we shipped it off to Pennsylvania. I wanted to know what the lead time was before I shipped it, and they should be no more than 60 days to have the pump returned. So
okay.
I haven't got a service report yet on it. That was just Thursday last
They
week.
give you a cost estimate?
Well, that's what the service report will yield.
Okay.
Yeah,
Okay.
they don't know. It's, it's a sealed unit, so.
There's, how many pumps there?
Two.
Two.
So
Yeah.
there's one
is doing all the work.
One currently.
Yeah.
Yeah. Which is not ideal, but,
Keep your fingers.
fortunately, we don't have high flow pump stations. I think Glendale does around 6,000 to 7,000 a day, and Goodrich does a little bit more. So if that did happen, if something happened for a month, one pumper truck with a couple loads a day could, and we have storage, in the pit itself. So
Yeah.
we could overcome it. Just, it'd be annoying, but,
But doable. Yeah.
yeah.
Problems with sewer are usually pretty annoying.
So you don't want to buy one of these $28,000 pumps and just let it sit. 'Cause
No, that's,
That they won't work when you need it.
Yeah.
Yeah.
Yeah. Unfortunately, that's exactly right.
Yeah.
Mike?
The special articles, as Tony was mentioning, we're going to do an article for engineering services. I talked to Dave Prickett. Moving forward with all the large projects the town's incurring in the future with the schools and maybe an EMS fire and the bridges, big projects coming across the table from the board for water main replacement and all that is going to get probably put off for quite some time. So I want to get a bunch of side streets, the ones that we can probably do through the rate structure, shelf ready plans, Yale Hill, Park Street, Sargent Street, increased fire flows. They're all old 6 and 4 inch water mains that you get a lot of rusty water calls and.
Any thoughts on Middle Road?
Not yet.
There's not enough money for that one.
the bottom of the list.
I know, and I've got a, actually.
Same word.
Yeah, Jay Bykowski was down and he's on a 6-inch main like that too. And this is the time of year that dense cold water flowing through, it's easily stirs the water up. I had a hydrant running all day for Berry Walk.
And just if you
Yeah,
have a chance,
I'll hit that one.
because it's nasty.
Yeah, yep.
So I thought that was a bigger main that goes through where Jay's is,
There's a 10 and a 6.
and he's on the
He's
6.
on the 6, yeah. Yeah. So, all the 6 always gives us trouble as we're rolling towards spring. It's always Ice Glen Road, your road, Park Street. Yep. Those are always the culprits for sure. And it would be even worse if you weren't looped, if it was the dead end, it would be,
Right.
yeah.
Like Park and.
Yeah, like an Ice Glen, yeah, so we're gonna do that. We're gonna get a bunch of shelf-ready plans out in front of the plant from the end of North Church where we ended our project to where we ended the project, where the cut comes out through the swamp on across from Pine Woods. That section is still 135 years old that we pump into with the water plant. That's 10-inch cast iron. That's about almost 10 feet deep in the middle of the road because the state raised it 5 feet years ago. So that's another one on the list. So we had the same situation where we had some surplus and we had to do something with it. So we're going to do that, and I'm going to do another 5 fire hydrants as well.
How many feet pipe are you proposing there?
It's
Right near the plant.
boy, I think that's 1,000.
I would say at least.
Yeah, 1,200, something like that. Like Yale Hill's 550, Sergeant Street's 800. Short little runs that the idea I have is that we buy all the stuff. We bid out labor and road repair. We buy we'll bring the steak to the restaurant type of thing. We want to bid out all the labor to put it in. We can, they don't mark up all the pipe. That's the way Barrington does a lot of their work. They do all of it.
That's how we got Park Street done years ago and with sewer.
Yep.
But what happened to the issue that we were thinking about with Wilkinson and what Great Barrington does?
We can't do it.
No?
No. Anything over $50,000 has got to go out to sealed bid, and we would be, that labor for
How
those.
did they get away with it?
I'm not sure how they work it, but Mike said we can't do it.
Okay. He knows.
Yeah.
Maybe because it's the fire district. No.
I don't know.
Yeah.
So that's the future plans, is just to try to get some shelf ready plans and then maybe get some ideas on labor from, and Dave said $350 a foot for those kind of 8-inch water main going into town road. Those are streets we don't need police details on. We can save,
That's true too.
we can save quite a bit of
And
get some pipe in the ground.
And maybe there's some money out there especially if you're shovel ready.
Yeah, well, as far as like grant work and whatnot, I mean, it's like Mike says we should borrow, but my thing is if we go out and we roll a rate structure payment in like the sewer station on Park Street, if we were to get $1 or $2 million to do a project, it's going to be a 20-year note for 2% money, and we're not going to see another project until that paid off.
Right.
Because it's rolled into the rate. So I'm just trying to think of a kind of a little bit more of a quicker way we can get a little more,
That makes sense.
Quick hits.
Yeah.
quick hits, quick, short, small, and we can put it in the rate structure and get that money like pretty quickly, I think. And not, our water rate is low compared to everyone around
That's
us.
one of the things when we talked about it before, because I've been on the board for a long time and we did different rates. And my feeling is, and I might just say it now, Mike was talking about, shall we do it a year rate? I'm into the thought of a 5-year
Yeah.
rate increase and not touch it for 5 years.
Yeah.
So let's adjust it accordingly.
Yeah.
And we don't have to keep on doing that.
It's-
Notifying people every year, the rates are going up, rates are going up.
Yeah, we have, I think
I think you endorsed that also.
it's 2021 since the last time we raised, and and the other thing is we've incurred a lot more costs, as we know. We're health benefits for us is coming out now. Our life insurance, retirement payments now that the town used to make are coming out of the water and sewer fund. So we're to the point where we are basically an enterprise fund without the actual true title. So we incur, each a third of Christine's health benefits and her salary and all that stuff too, and what goes towards her
It's a
retirement.
lot different than what it used
So where we were, the rate could be flatlined, that we've started to catch up, and health insurance goes up 8%, 9% a year. And, the salaries go up. So that stuff, as we keep rolling with the higher expense for all that, those 8% and the whatever percent with salaries, it hits harder.
I think you guys, when we have that meeting, you'll like the roadmap he's kind of created.
It's really, yeah.
I don't want to get out in front of it.
No.
Yeah. And the thing is, when you look at a 10 or a 20% rate increase, when your rate is low, it's not a really big impact to a 6-month water or sewer bill. It's not bad. So anyway, a couple more things. The Hillcrest tour, the kids came down, it went fantastic. It was really good. We love showing off our treatment plants, and the teachers and the staff were super impressed. They brought 4 kids. They had a ton of questions, very highly educated questions too, which was really, really
Good.
kind of fun. So they loved it. And our backwash pumps, we got one coming out tomorrow. We have a problem with one of them. And where we took that surplus money we had a few years back and we put it into a water not emergency fund, but a water main replacement and all that, and maintenance. We're going to pull the money out of that. I got bids on that. Mike said, move forward. We got a backwash pump, and nothing's been done to them other than grease and stuff. 30 years. This is our 30-year anniversary for the plant when they started construction on it.
Really 30 years.
1996.
Wow.
We went online in 97, but we started building the plant in 96. So, things are 30 years old, and we got, zero maintenance. Well, is zero big items. And when we did the backwash pumps, I was thinking, but they don't run anywhere near the amount of hours. But we got a problem with one of them. It's only pumping like half the amount of water we need. So that one's coming out tomorrow, and then they'll be done by the end of April with both of them. So, and I told the guys that the contractor, I said, you do not make a mess in this plant. We just had it all redone. The floor gets cleaned. I will get you soap and
When you come into
I will
the
get you
plant.
soap and scrub brushes to make sure this
Museum.
You put your little pads on when you walk.
So that's all I got. That's all. Yeah.
All right, so we're getting the hydrants flushed in Glendale Middle Road.
Yeah, we'll do that one.
Beautiful. Yes, Rosie. Anyway,
Donnie's hydrant.
John,
I'll make a motion that you have a question.
just one question. You're up for a reelection.
I took the papers out. I didn't see anyone else who wants
It's
to
good
run.
that somebody's up ahead and gets their papers early, so that people can sign them and not someone running around. Thank you, John.
I got my signatures in time.
The nick of time.
In the nick of time. So if we have nothing else, John makes a motion to
Make a
adjourn.
motion that we adjourn.
All right.
Sounds good.
So moved.